ちょっと待ってください。はい。ありがとう。I want to start my talk today by telling a story I think we're most familiar with. Searching for Ruby documentation is kind of hard. Often when searching for documentation, we get results that don't meet our expectations. Some results are for blog posts that sort of relate to what we're searching for. Other results are for documentation from Ruby from 3 or 4 years ago. The official Ruby docs are an excellent and reliable source of finding documentation. It has docs from Ruby version 2.0 to the latest and greatest version of Ruby, and even the development branch. And all the versions are separated by a path, so you won't have documentation leaking from one version into another. The Ruby docs also has a search function on the sidebar that lets you query the documentation. But you may have noticed in the past, when you've used it yourself, that RDoc orders its search results alphabetically. The order of these results can lead to an unoptimized set of results and can take a long time for users to scroll to find what they're exactly looking for. Taking an example search, in this case the toString method, RDoc presents these four objects as part of the top search results: argf, ADR info, array, and benchmark TMS. While some users may find what they're looking for here, I think the majority of users are looking for something else. There's an opportunity to use an alternative that we could use, one that highly boosts search results based on if the class is a core Ruby object, which are objects that people are most commonly searching for most of the time. So back in 2019, I started asking myself, could I build something that is able to consume and understand the Ruby source documents and understand what developers consider to be important and not important? And I did just that. In 2019, I made an app called Ruby API. This app solves problems for people trying to find and search documentation quickly. This is the front page, and please feel free to check it out during the talk. I'd love for you to browse it. I think it's really great, and I will hope you enjoy it too. It's a Ruby on Rails application, and it passes all the Ruby source and standard library documentation, builds links to the most common the most common object pages, and it has a search system to help find anything else. Ruby API supports multiple versions of Ruby, allowing you to navigate to the version that's best suited for your application. Elasticsearch powers the search with an index that optimizes for the most popular Ruby methods and objects. For example, the core Ruby objects like string, array, integer, float, symbols are scored much higher compared to other objects that are less common, and deprioritizes things that people, in my opinion, won't ever care about, primarily internal standard library objects like RDoc, RGEMS, bundler, etc. Recently, Ruby API has had a large uptick in usage. In July this year, Ruby API peaked at over 80,000 visitors and over 100,000 page views. I'm glad I could build something that people find useful, and thank you to everyone for the kind and welcoming feedback. Similar to the normal docs, Ruby API also allows you to see the method source code, including seed code. And my favorite feature of Ruby API is that you can execute any documentation example against a version of Ruby that's running in AWS Lambda. This is the string object page. It is everything you're already familiar with, like the method list, object ancestors, detailed descriptions, all pulled directly from the Ruby source code. When I first built Ruby API, I wanted to focus on the user experience. I wanted to use typography that was easy to read for long sessions, accessible colors, lots of spacing, etc. After I built Ruby API, I started to ask myself, how can I start improving the documentation itself? So good afternoon, everyone, and thank you for taking your time to attend my talk today. I'll be speaking about type signatures and ideas I have for improving the Ruby documentation ecosystem in Ruby by utilizing these signatures to create a more consistent and accessible documentation experience. For those who don't know me, my name is Colby. You can follow me on Twitter, that's my handle underneath, where I often talk about things I'm currently working on, ideas I have floating in my head. It's the best place to reach me if you have any questions after this talk. I flew here from the wonderful city of Melbourne in Australia. I took this photo last year at Albert Park Lake, where the Melbourne Formula 1 race is held every year. I also just wanted to say thank you to the conference organisers for allowing me to attend RubyKaigi in person this year. I wouldn't be here today without their help, and it's so great to be able to give talks and see everyone in person again after all these lockdowns and all these border closures. This is my cat, Claire. She's a 2-year-old tabby that helped me navigate the very strict lockdowns in Melbourne over the past 2 years and kept me company while putting this talk together. I currently work as a senior backend engineer at Calibre Analytics. We're an intentionally small company building a web performance platform to help create a faster and more equitable internet. We believe anyone can positively impact user experience given the right tools and page speed literacy. Please check out our site at calibreapp.com. You may be familiar with some of my previous work, specifically bundling Ruby gems. Unfortunately, during COVID, I have contributed very little to next to nothing at all to both projects due to the severe lockdowns, and my motivation just taken a nosedive. So during that time, I've been working on Ruby API. And so for the past few months, I've been working on a new feature in Ruby API that allows you to switch from the standard RDoc call sequences to the RBS type signatures. And we'll dive into what that means exactly. In Ruby API, when you click on the toggle button, it switches from showing the RDoc call sequences to showing you type signatures in RBS. The list of examples on how to use a particular method that you see in in the Ruby documentation are called call sequences. RDoc actually calls these calling sequences, but I much prefer them call sequence. It's much easier to say, trust me. When you look at the documentation for any method in Ruby source, it's almost always the method's call sequence you will see. It's a list of the different ways a method can be used that has been documented from the gem's authors and Ruby contributors. The type signatures on the right is an alternative way of presenting those method usages by utilizing the type signatures from RBS. And to better understand why this feature exists, we'll take a quick look at the current status quo and present some of the challenges that are currently present. Most people in this room will be familiar with RDoc already, but I want to give a quick rundown in terms of how documentation for Ruby source and the standard library currently works. If you're new to Ruby, firstly, welcome to the community, and I hope you're having a wonderful RubyKaigi so far. RDoc is the primary documentation tool we use for writing documentation for our libraries. And it's also the tool that all Ruby source and standard library docs are generated from. RDoc itself is part of the core set of libraries that is shipped with Ruby, commonly known as the standard library. You can find the source code at GitHub as part of the Ruby organization, where it's being actively maintained by the Ruby core team and contributors. Creating documentation for your code is very simple. Using comments, you can add documentation for your objects, methods, attributes, and constants. RDoc has a markup language to even format your document with styles like bold, italics, build links, lists, and other such markup. And the cool thing about RDoc is that you don't even need code in the first place. RDoc will happily read and format any RDoc formatted document and process it the same way. In fact, most of the docs inside Ruby source are formatted using RDoc files, the example on screen being the bug triaging guide. Once you have documentation, you can use the RDoc executable to generate a set of HTML files. On the screen is an example of running the RDoc command in your terminal. All you need to specify is which directory you want to generate your code from. Once RDoc has gone through all your source code, RDoc will run everything through a series of parsers to eventually generate a series of HTML pages with your documentation. RDoc also supports different formats. If you want to have output that was something different from HTML, you can easily define your own format. I have a fun question I want to ask the audience. Does anyone know what the POT format outputs? This format is part of RDoc. It's there today in the latest version of Ruby 3. I'll give you 10 seconds to think about it. If you need a hint to help you, anyone know the answer, just out of curiosity? No hands? No? To anyone that gets Microsoft PowerPoint, congratulations and good effort. Today's fun fact, if you didn't know, is RDoc actually supports taking your code documentation and turning it into PowerPoint slides. You can also very quickly programmatically generate documentation with RDoc. All you need are two variables. One contains the RDoc environment, and the other is a list of options you wish to pass in. In this case, the path of the code that includes our documentation, that being the current directory, the template RDoc we use to render the documentation to, and quiet flag to minimize the output to the console. Programmatically calling RDoc in this way is actually how Ruby API ingests the Ruby source documentation for each version. RDoc even supports code that's not written in Ruby. This code snippet is taken directly from Ruby source, specifically the string implementation. It's okay if you're not familiar with C. I won't be talking about it. I just wanted to show what this is specifically the empty method. I just want to show what it looks like. So the RDoc markup supports more than just basic linking and formatting. Something you'll see in the majority of documentation for the Ruby source is a special section called the call sequence. The call sequence contains examples of a given method's inputs and outputs. The example empty method is pretty simple. So it only has a call sequence that contains one entry that doesn't take any arguments and only returns a Boolean. RDoc puts a priority on the call sequence when rendering documentation to HTML. If the method's documentation has a call sequence, RDoc will generate the call sequence but not the name. If the method does not have a call sequence, it will just render the name. A more complex example, this one being the encode method for the string object. You can see multiple call sequence entries that describe the different inputs and outputs to the encode function. This call sequence also documents default arguments, keyword arguments, and the return types. Something important to know about call sequences is that Ruby source contributors and maintainers write them themselves. When a new method has been merged, someone must write the documentation, including when a method is updated. And this can present several challenges. Here's an example method, this one being the square brackets for the string object. This method has entries in the call sequence, sorry, has lots of method entries in the call sequence. And you may notice a couple of things that are a bit inconsistent here. Some arguments are just the name of the type of the input expected by the method, such as breakXP, integer, and such. But other arguments are the name of the actual argument itself. And sometimes the label for the thing returned from the method doesn't always line up consistently. There's also challenges for not just the content of the call sequence, but how it's also presented to users. If a brand new programmer looking at this call sequence may not know what a regex is, but I would like to know more information. I'm sure we can all remember when we first started programming how daunting the regex object can be. RDoc does not support generating links for the different objects being used, and it's left up to the user to go find that particular page. The other thing as well is there's no syntax highlighting. I really wish, and I'm sure a lot of people out here too, would also really wish that RDoc had support for syntax highlighting in the call sequence. So I started asking myself if there was something I could do to help solve these different problems. If keeping the call sequence consistent presents challenges to maintain, is there something else we could use instead? And the answer is yes, thanks to a new library that was released as part of Ruby 3. Before I can explain how we can automatically generate method sequences, I have to first talk about RBS. And this is a little bit ironic because there was just an RBS talk in this very room, so bear with me for a second for maybe repeating some content. So RBS is the new type signature for Ruby. It allows you to describe your application's objects, methods, attributes, and constants in a set of files called RBS files. And the RBS library is then able to validate your application is conforming to those type signatures. RBS is also part of the Ruby set of standard libraries. It's open source, and you can find it under the Ruby project on GitHub. There are two main components to understand about RBS. First is the RBS file, the thing that contains our signatures. You'll notice that it looks very similar to Ruby, but there are a few key differences. Firstly, this file is actually not Ruby, but it's a special kind of Ruby-like syntax specifically for RBS. There's no actual implementation code, and RBS files are just strictly for defining your signatures and your structure of your code, similar to a language like C and header files. Like call sequences in RBS, a method can have multiple signatures. This example being the gsub method from the string object. You can also define your own RBS files and have them type-checked by the RBS library. I've created this hello world application as an example. There's just a single method, and this takes a single argument and prints hello. I've also added a main.rb file that contains the logic to load the correct file, initialize the application, and call the hello method. A cool feature of the RBS tool is that it's able to create a starting template for your type signatures based off your existing code. Using the RBS prototype command, you can pass in a file you wish to generate an RBS file for, and RBS will render one to your terminal. For the most part, RBS has built a successful template. The only thing it's missing is just an untyped name argument on the second line. But we can easily substitute the correct type. For this demonstration purposes, I will just put string here for now as the only type. Reading RBS documentation, it's common to put your type signatures inside a SIG folder and have a structure that mimics your application's layout. So any signatures for your library code goes into the sig/lib folder. The RBS command unfortunately doesn't have tooling that makes it easy to work with your own RBS files, something I hope will change in the future. But the author of RBS has made another gem called Steep that allows you to type check your own RBS files very easily. Steep has a file called a Steep file, similar to Bundler and the gem file. The Steep file allows you to configure your Ruby environment to allow RBS to start type checking your own files. The Steep file is comprised of a target. You can think of this as a logical grouping of the files you want to be type checked, and also contains your type signatures. And when we run the Steep check command to validate our types, it will use your existing code, but it will also type check against your code with the standard library code. And even though we only had one type file, you can see for every dot, it's a different type check it's done. So it's also type check the standard library on top of your code as well. Let's quickly update our code to use an incorrect type. In this case, I've swapped out the string for an integer. And we can then run the Steep check command again to validate our types. And it will correctly find and identify our incorrect type in our code, and also print a nice error message. What's important to note about RBS is that your code will continue to run even though RBS has detected an incorrect type. I don't think RBS has a runtime component that will raise an error when an invalid type is used, but I could be wrong. You may be familiar with another type system from Ruby called Sorbet. This library has been available for a few years now and is from Stripe. I wish I could talk about Sorbet in this talk, but unfortunately I don't have enough time. Right now, Ruby API doesn't have support for Sorbet's RBI type signatures. The next feature I'm working on at the moment is importing documentation from Ruby gems. And if there is a considerable amount of support from gems using the Sorbet RBI files, I hope to work on adding support for RBI files in the future. Exhausting, isn't it? Thank you for taking your time for this long explanation. I'll give you a moment to give you a quick breath and recoup. Also from me. So going back to Ruby API, you now know the origins of what a call sequence is and where it comes from. And the same with type signatures. Ruby API has a very simple interface to import documentation. There's a rake task that downloads the given version for Ruby, unzips the download, and runs the RDoc tool. When importing documentation, the first thing that Ruby API does is prepare the local environment. First, Ruby API downloads a copy of the Ruby source from the Ruby Lang website for the given version. And not every version of Ruby supports type signatures, so we will do a quick check to see if we should continue. The next step is unpacking the RBS gem in the local file system, and this will let us access all the type signatures that RBS contains inside the gem. Next, if the version of Ruby that's been imported into Ruby API has type signatures available, we'll localize that and encapsulate all the RBS functionality. The argument you see being passed in is the path name to the folder that contains the extracted RBS gem from the previous slide. This class's main role is to set up an RBS environment, similar to how we create an RDoc environment. This will allow Ruby API to look up type signatures from the downloaded copy of Ruby source. A few notable things about this code. First is that we have to tell RBS to explicitly not load the standard library signatures from the Ruby version that's currently running this task. Ruby API could be executing this code on one version of Ruby, but importing a different version. So we want to prevent any signatures leaking between different versions. Next is that we immediately want to add the path that contains the standard library signatures that we unpacked from RBS earlier. Finally, we want to add the path that contains the type signatures for the core Ruby classes, like integer, string, hash, symbol, float, etc. Once we have an RBS environment, we can now look up the type signatures for methods. We have to check what type of method before we can query RBS. Instance methods and class methods are handled a little bit differently. And then once we have the name of the object, the method type, and the name of the method, we can ask RBS to give us the method's specific type signatures. Now, by no means am I saying that type signatures are a perfect solution. Type signatures also have their own challenges. One thing that may surprise people is that RBS and the RBS signatures themselves are kept separate from the Ruby source code at the moment. At the moment, the type signatures for the core and the standard library classes are all managed and live outside of Ruby source. This could potentially accidentally create a situation where the inputs and outputs of a method, the call sequence documentation, and the RBS type signatures could all be out of sync and could lead to some serious confusion from users. Maybe this will change in the future. Type signatures, first and foremost, have to be parsable by a machine, so they can build up the set of rules to validate your code against. So the type signature syntax is not particularly friendly for people. Here's a fairly complicated example. The signature is the string gsub method. There's a lot of entries, a lot of different types being used, even a signature that yields to a block. This signature is a bit tricky to read and to understand on the surface. And you may be wondering what this _TOS is. This is actually an interface. Specifically, it's the toString interface. It's a special type in RBS that checks if a given object implements the toString method. So, over the past few months, I've also been thinking, how can I improve type signatures to move from being machine readable to human readable? So here's the example from this is the gsub method again, so the gsub signature. So thinking of this, there's definitely some obvious things we can do. So the first thing I would like to see as a step towards making this readable for people is removing all the double colon marks that prefix all the class objects. And you may notice this thing. In RBS, some of the types have just int, spelled int. Others are just integer. And to be honest, I'm not actually sure why that's the case, and maybe someone can hopefully explain it to me here. Next, I feel the round brackets are a bit unnecessary most of the time. So let's remove those for now. I don't know 100% if that makes sense. There could be cases where we do need the brackets. Lastly, it's still a bit difficult to read, so we should add some color. Ruby API doesn't currently have support for syntax highlighting for the type signatures, but I would very much like to see it added in the future. This is starting to look much more readable now. How do you feel about it? Is there something else we could do? What I would absolutely love to see as well added in the future is the ability to parse the types in the signatures to build out links to those classes. Not everything will map one-to-one, but I think there is a very good use case for it. If someone is new to Ruby and is unsure what regex is, or if you want to refresh your knowledge on a range object, you can just click the link to keep reading on. Here's a before and after, and I think there's some good first steps to make type signatures more readable. There's more we can do, obviously. Because RBS is a structured language, we can add, move, and rewrite these signatures to help create a better user experience. Maybe we could add tooltips or plain text versions that are more readable and text-friendly. I want to know more what we can do from you. All these ideas I've shared today have been things stuck in my head for a long time. And these have not been proposed to the RDoc, RBS, or the contributors to Ruby source in any way. I would love to sit down with them sometime during RubyKaigi or afterwards and continue to sort of share ideas and start potentially working on some of these ideas. I'd also like to hear your ideas from anyone else on what else we can do to help improve Ruby's documentation. Is there something I've missed? You can find Ruby API on GitHub. We're a fairly small community, but I certainly welcome any feedback and ideas on how we can improve Ruby documentation. I would love to test ideas on rubyapi.org that can eventually be merged back to RDoc in the future. If you're interested in learning more about types and Rubies, I recommend checking out the other type-related talks that are happening at RubyKaigi over the next couple of days, or in the VODs that are posted after the conference. Lastly, I know the documentation is kind of boring and not very exciting, but having a good language and API documentation is very important for a healthy language ecosystem. I'm really passionate about this topic, and thank you for taking your time to listen to my talk. ありがとうございました。